Hey guys, Lindsay here, and today we're going to take a few minutes to look at factoring, but we are going to factor in the form x squared plus bx plus c. And if you haven't seen that before, something that's important to know is that the b right here does actually represent an actual number, and so does the c, whereas the x's are variables. Now, for example, these are x's here. Over here, they're a's. Either way, they're a variable. So if we take a look at this example first, and we go back up to here, does it make sense that the b in this equation would be the number in front of x, which would be 3? So in this equation, our b value, and I can write that for you if you want, our b value is equal to the number in front of x, which is 3, and our c value is equal to 2. It's the constant, it's the number sitting by itself. And the reason that that's so important is because the way that we're going to factor this, now this is a quadratic, but the way that we're going to factor this quadratic is we are going to think of two numbers. And if you look over here, you can see our two numbers that we're going to think of. They need to add to our b value, which in this case is 3, and they need to multiply to our c value. And in this case, it's 2. Now this method does only work, and I thought I should probably mention it just to make sure. You can only have a 1 sitting out front. You can't have any other values sitting out front of that x squared. We'll take a look at that another time. There's a couple different ways to think of it, and as you get more comfortable, it'll probably flow a little bit easier, but let me take you through it step by step first. Add to b, multiply to c. So let's focus on, I'm going to write that down. So we're going to add to 3, and we're going to multiply to 2. Let's focus on the multiplying, and let's think of two numbers that multiply to 2. Now, in this case, the only two numbers that I can think of that multiply to 2 are 2 and 1. And now we're going to go back up and we're going to say, do those two numbers add to 3? 2 times 1, 2. 2 plus 1, 3. It works. So if I want to factor this, I'll write it down here so it's a little clearer. I've got x squared plus 3x plus 2, and I want to factor that. The way that I'm going to do it is I'm going to come up with two sets of brackets. There's an x as our variable, so I'm going to put an x in the front of both of the brackets, and then I'm going to put my two numbers, the 2 and the 1, order doesn't matter, they're both positive, so a positive 2 and a positive 1 in those brackets. X squared plus 3x plus 2 factored is x plus 2 times x plus 1. Now that one was kind of straightforward, so maybe let's look at this second example that's got a little bit more to it so you can kind of see the pattern of this factoring. So this time we need to think of two numbers that add to 9, and those same two numbers need to multiply to 20. And again, there's more than one way to do this, but the way that I think is the most easy to follow is to first worry about multiplying. So let's think of the ways we can multiply to 20. So 1 times 20, well, that equals 20. 2 times 10, that equals 20. 5 times 4 equals 20. And those are the only ways that I can think of that we can multiply with positive numbers to get to 20. Once we've got those pairs, it's going to make it a lot easier for us to find our numbers, because now we just have to look at the pairs and figure out which two add to 9. 1 plus 20 doesn't. 2 plus 10, that's 12. That's not 9. But 5 plus 4, that's it. That's the numbers we need. That's kind of the hard part of the question, because once you have those two values, I can write my two brackets. I'm dealing with an x here, so I'm going to put an x in the front of both of those brackets. And I'm going to put a 5, and that's positive 5. We'll deal with one with a negative in a second. And a positive 4 in those brackets. So hopefully that makes sense, and you're starting to kind of see the pattern. We're going to take a look at one more example. So in this case, we are going to take a look at two values that add to negative 15 this time. So let's write that down. So we're going to have to deal with some negative numbers, but that's okay. The process is still the same. And they need to multiply to 36. Okay, so I'm going to deal first with multiplying. So 1 times 36, that would be 36. 2 times 18, that's 36. 3 times 12 is 36. 4 times 9, there's a lot of them here, is 36. 5 won't, but 6 times 6 is 36. I think that's all of the ways that we can multiply to 36. And now we need them to add to negative 15. So right now, none of those are going to add to negative 15 because there's no negative signs there. But what we can do is, think about this for a second. If they have to multiply to a positive number, but they have to add to a negative number, the only way we could possibly do that is if all of these values are negative. Because negative 1 times negative 36, that's still positive 36. And it would work all the way down. Two negatives multiplied together makes a positive. But when they add together, now we're going to get our negative answer. And if we take a look down our list, it looks like negative 3 plus negative 12, or negative 3 subtract 12 would be negative 15. So those are our numbers right there. And once we've got those numbers, again, that's the hardest part, we are now going to put our two brackets in. This time we're dealing with an A rather than an X, but that's okay. It doesn't matter. We're just going to put an A in front rather than an X. And we're going to put our two values. Order doesn't matter. I could put a 3 there and a 12 there, or vice versa. A negative 3 in one bracket and a negative 12 in the other. And if you wanted, you could take a minute and you could FOIL that, multiply those two together to get your final answer, and it should be your original question, and then you know you've done it correctly. So hopefully that clarifies for you a little bit, factoring in the form x squared plus bx plus c.